Welcome back to section 2.5, taking a look at literal equations and formulas. Ideally, from class, I handed off an outline to you, and you are being asked to complete this outline as follows. So keep in mind, this paper will be checked in class for credit, and all you really have to do is write down everything that I'm writing down, fill in the blanks where I fill in the blanks, write down any examples that I make a note of. In addition, to keep organized, make sure that you write down who you are so that we know these are your notes. So I know that Mr. Cortez is completing this. Write in the date here, whatever that might be. Starting first with a little bit of vocab, dealing with literal equations and formulas. So far we've been working with equations, trying to solve for, let's say, x where it was equal to some number, or z was equal to some number. We introduced the idea of using opposites to solve these. Seeing if we use addition, use subtraction. If we see subtraction, use addition. Same ordeal with multiplication and division. These undo each other. So with the vocab over here, we'll get a feel for exactly what makes up a literal equation. So a literal equation is really something that we've already seen, because we've seen equations, that's for sure. But now, since this is considered a literal equation, this is where there can be two or more variables. And so what does this mean? Normally we have something like x plus 7, and then that's equal to some number, and we could solve for it. But now, to have an additional variable, it might be something like this, where we won't necessarily solve for one of the variables. Sometimes we will. Sometimes it depends on which variable we're trying to solve for. But really, the idea here is that there are two or more variables. That then leads us to a formula where, if you're taking physics, you've probably seen this quite a bit, potentially with distance equals rate times time. And the idea here is that this is still an equation, but now it states a relationship with quantities or variables. So in physics, you might have seen distance equals rate times time. That's an example of a formula. In this section, we'll be using formulas, we'll be trying to isolate one variable, and we'll be using the steps seen here, where of course we're trying to answer, what do we want to solve for? What variable do we want? Do we want x? Do we want z? Do we want y? Where is the variable in the literal equation? Is it going to be on the left side? Is it on the other side? Is it 15? Where is the variable? That's what you should be asking yourself here. In addition, I try to make a goal whenever I solve these problems. So I'm trying to identify what operations I need to isolate that variable and where I can apply them. Also using inverse operations to make sure that that happens, and eventually isolating the variable, which is your goal. So as I work through these examples, I'll be referring to those steps. This first example has us with x plus y equals 15. And we're solving for x. So when this says we're solving for x, our goal is to have x equals something, whatever this might be. But this is our goal. We're trying to have x equals some term or set of terms. So we've acknowledged where the variable is. I see x right here. I know that if I refresh this, I see x is on the left-hand side. So how can I go about moving these other terms over here? What's on the left side that's not x? Well, I know that y is here, so how could I get rid of y if it's positive? You can subtract, for sure. And where I see students trip up here is that they'll acknowledge that x drops down, dropping that x like it's hot. We then have 15 and we're deducting y. And so it seems odd that we're not going to take this problem any further, but in reality, this is our answer because it matches our goal. And I think where students trip up is that they'll try to take this further, but note, 15 and y are not like terms. It's really crucial to acknowledge that. If we see the next example, we're solving for q. We see that p is multiplying with q, so how can we undo this? How can we just end up with q equals something? Since these are multiplying, we can use division for both sides. We can divide both sides by p because we're trying to get rid of that. The variables cancel, which is good. We're then left with q equals x over p. This matches my goal, so I'm pretty content with this. For the next two, these take a little bit more work, but it's nothing we can't handle. I know that I want y to be equal to something. You may want to pause this if you're feeling comfy and try this problem out. But I'm trying to isolate y, so that means that I need to move this 10x. So if I deduct 10x here and here, 5y is now equal to negative 10x plus 40. How can I go about isolating y even further? You should be dividing both sides by 5, leaving you with y equals negative 10x plus 40 over 5. Another option you have is to separate this into two fractions. Then you could potentially take this further to negative 10 over 5, which is negative 2. And x is along for the ride, so using division here. And also 40 over 5, which is going to add on 8. And this matches our goal. What can we do for the next problem if we're solving for t? T is pretty close to being isolated, but what's holding us back? The 2 is definitely holding us back. So if we divide both sides by 2, we could just cancel our 2's and be left with t equals 5 minus b over 2. It's totally okay. Another way you could rewrite this, similar to what we have up here, we could break this into two fractions, 5 halves, and then subtracting b over 2. It's also fair game. The wordy example seen here we'll talk about in class. If you want to try that on your own, go for it, but in class we'll most likely talk about that. Down here for the summary, I want you to write down one sentence that you think summarizes this section. So how I think this section is important is because we've seen equations, we've seen that build into now, where we're really only working with variables. So the summary, I think what's good is that, well, we've done everything here, so this is similar to previous sections. State a goal and solve. Solve for the specific variable. I think that sounds a little bit better, because as you can see here, we have more than one in all of these problems, so it helps if we're solving for the specific variable. If you have any questions on this outline, come to class with them, email me with them. Again, my email's seen here. And we'll practice this more in class.